In previous videos, we talked about different aspects of pupil size, but right now we want to talk about depth of field and pupil size. So depth of field is a very important topic in any optical system. So first, let's talk about the depth of field. What is depth of field? So field, you can see right now, we have three images. First image, second one, and the third one. And the distance from the first object to the last object to the fifth one is a constant distance. But right now we are taking photos, let's say, with three different cameras. With camera one, when the first object, which is close to the camera, is in focus, that you can see is very sharp, the edges are very, very sharp. Then when you increase the distance for any other object, the rest are not in focus. For the second one, the first one is sharp, the second one is sharp, the third one is somehow not that sharp, the fourth and fifth one are not sharp. But in this one, you can see all of them are sharp. So when you want to compare these three images, we can say that for the first one, the depth of field is small because, we only have one object in focus. This one is a little bit longer. This one is good depth of field, has a very good depth of field because we can see 5 objects, all of them are in focus. So this one we call it shallow depth of field. This one has higher depth of field. So depth of field is the ability, let's say it's the ability to see a few objects at different distance, all of them in sharp focus. That's the ability of any optical system. Sometimes, we change the depth of field to just have one object in focus, the rest are not in focus. So now for our optical system, which is our eye, we need to actually talk about depth of field of our eye. What is the effect of the pupil size and depth of field? So as I mentioned, always our optical system, which is our eye, is exactly like other optical system. We have a stop and depth of field. So the depth of field is a function of 2u2 n c over f2. The rest are not that important for us. But in this equation, we can see n is the f number, which is equal to the focus, focal length divided by the diameter. And the diameter here is the entrance diameter. And entrance diameter is somehow related to the size of the stop. For now, for simplicity, just let's say focal length of our eye divided by the radius of the stop. So in this equation, you can see when the diameter of the pupil goes down, f, let's say f is constant, we are looking at some object at specific distance, and our eye is at some constant optical power. So when f goes down, this whole n goes up because it's in the denominator. When n goes up, the depth of field goes up. So from this equation, you can see that when the stop diameter or the pupil diameter gets smaller, our depth of field, when this one goes down, this one goes higher, our depth of field goes higher. So when the stop goes higher, we can see a lot of objects at different distance. But when the stop is bigger, then this one d goes up and goes down, and the depth of field goes down. So there is a opposite relationship between depth of field and the diameter of the stop. And that's another things that related to our eye. And right now you can see for these three images, it depends on how you can look at them. So for this image, that the depth of field is small, the diameter of the stop is high. But for this image in our brain, something that we can see, when the depth of field is high, so it means that the diameter of the stop is smaller. Thank you very much. And here are some references that I use.